Well, for hydrogen emission and absorption, I guess part A is asking for the shortest wavelength of light. Okay, so the shortest wavelength means the highest energy, or the highest energy difference between levels. And we're going into emission. So if emission means if we're starting at level 4, that means we have to end up at a lower level. And the lowest level we can go through is level 1. Okay? So I know that I'm going from 4 to 1, based on the fact that it's the shortest wavelength and it's emission. So the wavelength for that transition can be gotten from the Rydberg formula. 1 over 1 squared minus 1 over 4 squared is 1.03 times 10 to the 7th inverse meters. And so the wavelength is 97 nanometers per part. Okay. For part B, the longest wavelength of light that can be absorbed. Well, the longest wavelength is the lowest delta E. Okay, and we're in absorption. And if we're starting in n equals 4, then that must mean we're going to n equals 5, right? We want the closest level so that we have the lowest energy. And we are in absorption, so that means we have to go up a level, right? So that gives me my starting and ending level. So again, I can use the Rydberg formula. And this time it's 1 over 4 squared minus 1 over 5 squared, which gives me 2.47 times 10 to the 5th inverse meters. So lambda is 4.05 times 10 to the minus 6 meters. 4.05 micrometers, if you wish. For part C, which has a greater energy difference, level 4 to 1 or 4 to 7. Calculate both and compare. Okay, so energy difference. Well, if we go from level 4 to level 1, the energy difference, well, let's see. If level 4, well, if we're going from 4 to 1, we want to subtract higher minus lower to get a positive energy difference. So the energy of level, we're going to do E4 minus E1, right? So that's negative 13.6 over 4 squared minus negative 13.6 over 1 squared. So that's 12.8 eV. Okay, and going from level 4 to level 7, the energy difference, again taking highest minus lowest, is negative 13.6 over 7 squared minus negative 13.6 over 4 squared. And that is only 0.57 eV. So the bigger energy is going to be from 4 to 1.